Welcome to part 3 of the lesson on graphing equations by plotting points. In example 3, we want to use the equation y equals 2 raised to the power of x to complete the table below and then graph the results. Looking at the table, notice how we're given the inputs or x values, so we need to perform substitution into the equation to find the corresponding outputs or y values, write the ordered pairs, and then plot the points on the Cartesian plane. For this example, we'll assume we're not familiar with negative exponents or the exponent of 0. Let's begin with the input or x value of positive 1. So when the input is positive 1, the corresponding output is going to be y, which equals 2 raised to the power of 1. So we have y equals 2, which means when the input is 1, the output is 2. The ordered pair is 1, comma 2. The next input is 2, so the corresponding output is going to be y equals 2 raised to the power of 2, or 2 squared. So we have y equals 2 times 2, so we have y equals 4. So when the input is 2, the output is 4. The ordered pair is 2, comma 4. The next input is 3. So the corresponding output or y value is y equals 2 raised to the power of 3, or 2 cubed. So here we have 3 factors of 2. So we have y equals 2 times 2 times 2, so y equals 8. Which means when the input is 3, the output is 8. The ordered pair is 3, comma 8. The next input is 4, so the corresponding output is y equals 2 raised to the 4th power, or 2 to the 4th. So we have 4 factors of 2, so we have 2 times 2 times 2 times 2, so we have y equals 16. When the input is 4, the output is 16. The ordered pair is 4, comma 16. Now see if we can determine the remaining outputs or y values by looking for a pattern in the table. If we start at the input or x value of 1, notice how as the inputs increase by 1, the pattern for the outputs or y values is that we multiply by 2. 2 times 2 equals 4, 4 times 2 equals 8, 8 times 2 equals 16. Which means if we go up the columns, the inputs are decreasing by 1, and the pattern for the outputs or y values is that we would now divide by 2. 16 divided by 2 equals 8, 8 divided by 2 equals 4, 4 divided by 2 equals 2, and because 2 divided by 2 is equal to 1, we know this output here must be 1, meaning when the input is 0, the output is 1, the ordered pair is 0, comma 1. Now if we try to find this output by performing substitution with x equals 0, notice how we would have y equals 2 raised to the power of 0, which we now know must equal 1. And it is true, any non-zero base raised to the 0 power will always be 1. Continuing with this pattern, 1 divided by 2 is equal to 1/2, which means when the input is negative 1, the output is 1/2. The ordered pair is negative 1, comma 1/2. If we try to find this output by performing substitution, we would have y equals 2 raised to the power of negative 1, which we now know is equal to 1/2. We can actually write 2 to the negative 1 as 1 over 2 to the power of positive 1, which is 1/2. If we continue this pattern, 1/2 divided by 2 is going to give us the output when the input is negative 2. So let's figure out what 1/2 divided by 2 would be. Well, 1/2 divided by 2, if we want divided by 2 over 1, is equivalent to 1/2 times the reciprocal of 2 over 1, which is 1/2, and 1/2 times 1/2 is equal to 1/4. So this output is 1/4. The ordered pair is negative 2, comma 1/4. Notice how if we continue dividing by 2, or if we want multiplying by 1/2, the outputs are going to get smaller and smaller as the inputs decrease by 1, and they're going to approach the value of 0, even though they'll never reach the value of 0. Now let's set up our Cartesian plane, plot these points, and sketch our graph. Notice how the inputs, which we always find along the horizontal axis, start at negative 2 and go up to 4, and the inputs are always going to be positive and go up to a maximum value of 16. So let's go ahead and sketch the horizontal axis lower than we normally do because there are no negative outputs. So let's sketch it here. And let's go ahead and sketch the vertical axis, let's say here. We'll label the horizontal axis the x-axis because the input variable is x. We'll label the vertical axis y because the output variable is y. Now we'll scale the horizontal axis by ones, but we'll let every 2 grid marks be equal to 1 unit. So we'll put a tick mark every other grid mark, here, 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 and so on. Again, scaling this by ones, so we'd have 1, 2, 3, 4, and so on. To the left, we'd have -1, -2, -3. Now for the vertical axis, we have to go as high as 16. So let's go ahead and scale the vertical axis by 2's. But we'll let every other grid mark be equal to 2 units. So we'll have 2, 4, 6, 8, and so on. Now we'll plot the points given by the ordered pairs. So the first ordered pair is -2, 1/4. So the input is -2 and the output is 1/4. So here's where we have an input of -2. Because the output is 1/4, we go up 1/4 of a unit, which would be just above the horizontal axis, let's say here. The next ordered pair is -1, 1/2. So input is -1, output is 1/2, should be approximately here. The next ordered pair is 0, 1. The input is 0 here, because the output is when we go up 1 unit to here. Next ordered pair is 1, 2, input 1, output 2. Next ordered pair 2, 4, input 2, output 4. Next ordered pair 3, 8, input 3, output 8. And finally we have 4, 16, input 4, output 16. So the graph of y equals 2 raised to the power of x must pass through all these points. And we can remember, as the inputs decrease, the outputs or y values approach 0, but never actually reach 0, which means our graph is never going to touch the horizontal axis, where we'd have an output of 0. So the graph will look something like this. And whenever a graph approaches a horizontal line but never touches it, we say that horizontal line is called a horizontal asymptote. So this graph does have a horizontal asymptote, which would be the horizontal axis. Before we go, let's check our work on the graphing calculator. So from the home screen, we'll press y equals, enter in our equation of y equals 2 raised to the power of x. We'll clear out this old equation here by pressing clear, and we'll enter 2, here's the exponent key, raised to the power of x, enter. Let's first check our table of values, but let's first check our table set. So we'll press second window. Right now the table is going to start at -2, which is good. The change in the table is by 1, which is good. We want the independent variable to be on automatic, which it is. So if we press second graph, we can check this table of values with ours, but just notice how the fractions here are converted to decimals. 0.25 does equal 1/4, 0.5 does equal 1/2, and as we scroll down, you can see our table matches the calculator. And if we scroll up, we can also see that as the inputs decrease, notice how the outputs or y values are approaching 0, but they'll never actually reach 0. Notice here the outputs are expressed using scientific notation, and that's because they're very small, still approaching 0. Now let's check our graph. Before we do this, we want to check how we've scaled the axes. So let's go ahead and press the window key, and our horizontal axis goes from -3 to 6 by 1, so we'll enter -3, enter 6, enter by 1s, enter. The vertical axis goes from looks like -2 all the way up to what looks like +18, so -2, enter, +18, enter, by 2's, so the y scale is 2, and now let's go ahead and press graph. And notice how our graph looks just like the graph on the calculator, which verifies our graph is also correct. I hope you found this helpful.